for the introduction, in this group project, each group is given a task to come up with an equation consists of addition, multiplication, subtraction, and etc. So after creating an equation, it needs to come with an assembly language code for the equation, then test on LMC. So what is LMC? LMC is also known as Littleman computer. It's an instructional model of a computer created around 1965. So it models a simple one human architecture with all the basic features of a modern computer. So let me explain further about LMC. So LMC, the 100 memory address in the computer memory are numbered from 0 to 99 and can each contain a machine code instruction or data. So each assembly language instruction is made up of 3-letter mnemonic, which represents the operation code, usually followed by the memory address of the data the CPU is to act on. So the input box allows the user to enter the numerical data while a program is running and load into the accumulator. So a RAM memory address that is used to store data can be given a meaningful label, and the program counter stores the memory address of the instruction being carried out. It will automatically increment by one after each instruction is completed. So if the CPU receives a non-sequential instruction to branch, then the program counter is set to the memory address of the instruction. So to restart the program counter is reset to 0.
Okay, hi, my name is Arvind Chidambaram, and my matrix number is CE200100. So today I'll be explaining assembly language code. So this is the code that we'll be using. So before that, you need to understand that for this little man computer, you can't do multiplication or square root or division. So you need to use subtraction and add to get your value. Now before that, I'll be explaining this part, the assembly code. So for the simulation, my friend will be doing simulation. So before that, let's go to the okay, so the assembly language code. So before that, you need to understand the equation. So for my group, we choose a square minus b over 3 plus d, 3 times d plus e. So for the first part is you need to do a square. Okay, now let's go. Okay, so for this part coding, as you can see, so for the Littleman computing, you cannot do multiplication and division. So for that, you need to use loop and also add a load, add and subtract, add and load. So for this part, I first input, then you need to store a, load a. So the input is stored at a. Then you need to store the value of a in z. Then the loop starts for z. Then you need to subtract y, then store it z. The value, the load z, subtract with y, then z. Then you need to load answer, add a, and store the answer. So then the loop start again, and then it's end. So load answer is, so the final value is in load a and s. So then then the value is stored at 99. So if you go on Littleman computing, there's 99, 100 is 99. The data is stored in load 99. So then it's set out 99. Then the answer is substitute, then store answer back, then load at 99. So this for a square. For the next part is negative p, minus p. So a square minus p. So for that, you need to put input b, then store b. Then as you know, the a square value is stored at load 99. Then you need to substitute with p. The value b you need to substitute. Then this value you need to store at 98. 98. So for the next part is c plus times t. So as I said before, you can't do multiplication and division. So you need to use add and subtract and load and loop. So first you need to input, then substitute the input with y, then store it c. Then again input, then store at t, then load at t, then store at 97. The load input t is stored at 97. Then load c. You need to loop c, the value c. Then load t, then add 97. Load t and add 97. Then store at t again. So the next one is load c, substitute y, the value y, and store at c again. Then there's two loop. So loop, not two loop. Then you need then later on is n. Then load d. Then the value is stored at x. Okay. Stored at x. Yes. Sorry. So for the next part is positive c with plus c, the value c times t is plus with e. So now for this is the value is the final value is load at x. So as you know, then input you need to add an input. Then the input is stored at t. Then load x. You need to load the x. Then add with t. As you can see, add with t. So then this value x plus e you need to store at 96. Okay. So for the next part is division. So as I said, all the you can't do the division. You need to use loop, subtract and add. So now load 98, 96, and 90. So this is the value that we all put. All the data is stored in 98, 96, and 90. So then this data you need to store as G. Then loop 98. When you loop 98, then load 98, then substitute with 96. Then store at 96 again. So then next part is you need to load G. Then add Y, then store at G. Then loop. Then extend the loop, load G. Then the value of G you need to store at 95. Output is at 95. So this is the final value. This is the final value. So next, this is important. You need to declare each part, each value. For example, how many time you did, and this coding is important. Without this, the coding will not run. So that's all for me. So for the next part, which is simulation, my team member will be doing it. So thank you.
Hello, I'm Prabharan son of Kalayasan. My metric number is CE200075. I'm from group 12. In this video, I'm going to explain about the assembly language code and simulation in Littleman computer. this is the equation of our team, that is a square minus b divided by c times d plus e. So now I will show the simulation of this equation in Littleman computer. Okay, this is the Littleman computer program, and this section is to write the assembly language code, and then this is the assembly language code for our team's equation. First of all, we have done the a square. So for your information, in Littleman computer, we cannot directly done the operation such as squaring and multiplication and division. We can only do by the addition and subtraction. So this is the code for a square. This is start with the input. So the input, we have to give the input, and the input will start as a and load a to start as z, and then this line load the z again. This is where the loop begin. Okay, this BRZN is the key of our loop. This BRZ will continue the loop if the value in the Z more than 0. If the value in the Z becomes 0, it will break the loop and straight away jump here. And so this line will start to execute. For the a square operation, we have to give the input 4. So the 4 will start in A and Z. So because this line is load A and store as Z, so the 4 will in the A and Z. Then the Z was loaded and the loop began. The value in Z minus with Y. The Y value is being declared as 1, so minus 1. So and stored again in the Z. The load ANS is a blank data, so it will add the A into ANS, store again as in ANS. After some times, the Z value in the Z will become 0, so the loop will break and straight away start here. The addition of the answer is in this data, so it will load this ANS and stored as address 99. So the output will show in address 99. Okay, let's check the assembly language code for a square. So to simulate this program, we have to submit this code and run, and then we have to give the input for a. So if we give 4, so the output f2 16, because the value of a is 4, so 4 square is 16. Okay, let's check. Okay, the output is 16, so this code is correct. Okay, the next operation is subtraction. The code for the subtraction is start from here. Input, we have to give an input. It will start as b, and then this line was to load the address 99 because the previous value is stored in 99. So if the line was loaded the 99, and this line will be subtract b with the value in 99. So after subtract, the answer will be stored in address 98. So output will show in address 98. So okay, let's check. So we have the output 16. So if we have to minus any value. So for minus, I give input 6. So enter. So if we give 6, the answer have to 10. Okay, the answer is correct. Okay, the next operation is multiplication, which is C multiplied with D. So we have to give the input, two input for C and D. If we give one input, it will store in C, and another input it will store in D. So it will load D and store in address 97, and then it will load C to start the loop. If the value in C becomes 0, it will jump here, but the value in C is more than 0, it will continue the loop. In this loop, it will add and subtract the value until we get the answer for multiplication. Okay, let's check the multiplication operation. So we have to give a 2 input. We gave 2 for C and another 2 for D. So output, the answer will 4. Okay, this is correct. And then the next operation is plus. This code shows the addition operation. Input, we have to give an input, and the input will start in E. So it will load X because the previous value was stored in X. So it will load X and add E, and then start in address 96. Okay, 96. So I have gave the input 1. So if I click enter, it will plus with the 4. It's become 5. Okay, 5. Okay, the division is already done. Yeah, I explained how this division is done. Okay, the division operation is start from here, because after we add E, this line load the address 98, which was the 98 is 10, and then it load 96, which is 5, and then it will run in this loop and until we get the answer in division. So 10 divided by 5, answer is 2. This section is to declare the data we have used. For example, A, B, C, D, all the alphabet we have used in this code, we have to declare. If we do not declare, the code will be not run. And then this HLT is to stop the operation and program execution. Okay, that's all from me. Thank you.
Okay, hi, my name is Aravindan Shambalam. Matrix number CE2001. So for discussion part, we use Littleman computer. This Littleman computer, which is sent for LMC, it's the type of software used to run assembly code. So for this project, we choose an equation that has a power of 2 and multiplication division on our equation. So, but there was a problem in LMC, Little Man Computer. The Little Man Computer can't do multiplication and division directly. So the solution was we need to use looping to get our result. So with this, we gain some knowledge on how to use Little Man Computer. So that's all for me. Thank you.
So in conclusion, we learned the use of LMC simulator. So we are able to run the general equation that we created for this project and then compare the calculation with the data. So and also we were able to come up with the assembly language code for the derived equation. And also we observed every step of execution process. By changing its value, we can learn about the data and how the program counter, instruction register, address register, and accumulator work. So this LMC simulator cannot perform multiplication, division, or power operations. So using looping to solve general questions of power of 2, with that result is gained according to the manual calculation of the equation. So finally, we completed our project and met our objective. So that's all from us. Thank you.